Sensor technology using capacitance can be doing a lot of things, not just touch. Can you tell us about some of your sensors here? Some of them are measuring flexibility.
Yeah, I guess angular displacement is what the kind of more technical term. So that is our main kind of application, is measuring bending, hence the name Bend Labs. We also can do stretch-based, and kind of fairly new is pressure. So yeah, this one's our pressure sensor, kind of a prototype version. You can see it's a little bit harder to get accurate data when you're holding both sides. But you can see as you press it, the graph increases, and it is sensitive, this one particularly, up to about 100 pounds of force. And you can see that it's pretty accurate. It's measuring at 500 hertz here.
Okay. Now, how does this work? Because obviously there are other pressure sensors and things like that, but they probably use much different techniques.
Yeah, so the kind of main differentiating factor is that we are capacitive based. We use ink-based flexible material that we essentially make electrodes out of silicone with conductive ink and use that to design capacitors of certain geometries. And depending on the geometry, you can get a lot of different readings.
It sounds like you can actually customize this for a particular application.
Yeah, we can print essentially any geometry. There are some constraints on it. I guess I wouldn't necessarily think about it like 3D printing, but we could make our layer stack up very customizable. We've done insoles for shoes, measuring people's gait. We've done stuff inside of virtual reality gloves. We've got we got a bunch of different applications that I wish I could memorize them all. But yeah.
Now, what type of capability does this have in terms of measurement, accuracy, and so on?
Yeah, so we can get to like plus or minus about 0.1 degrees in bending with the 1-axis, 2-axis sensors, and the stretching to 0.5 millimeters plus or minus.
Okay. How does this interface to a processor? Does it require a special interface, or can I use a conventional micro?
Yeah, so our standard protocol is I2C. We've done custom boards that are straight, just Bluetooth, no actual digital interface. We've done analog out, which is useful for a lot. We've got companies that try to measure 15 plus channels, and they've got data acquisition units, so they just want the analog out so they can capture the data a lot quicker. Depending on, I guess, the amount of investment, we can give you any digital interface you want, but I2C is our bread and butter, I guess. This is our 1-axis typical sensor with a Bluetooth module on it. So you can see that it does angular displacement here. We can go to all of our angles. We can wrap it all the way around. You can get over 360 degrees. It also does stretch, which you can see kind of in the blue graph, or this kind of ball and rectangle. You can stretch it 50% of the length of the sensor without damaging it. You can impulse stretch it to 75% without damage. The stretching is plus or minus 0.5 millimeters of accuracy, and the angular displacement at the same time is plus or minus 0.1 degrees.
Well, thank you for showing us how sensors can be flexible.
Yeah, no problem.